This video is going to look at how we can master half-life questions in the exam. Got 5 questions we're going to look at, so pause the video at any point on these questions and have a little go, have a little think about how you might answer them first. Okay. Question 1. It says here, how many years will the source need replacing? So all half-life questions, it's really important that you have access to a ruler. So we've got the mass in micrograms is 6. So half of 6 is going to be 3. So we draw a line at 3. And then where we meet the intercept, that gradient there, we can draw a line going down. Now half of 3 is 1.5, so we do another one just to make sure. So it's important to take our time with these. Which will be easier with a real ruler for you. But we go along and then we go down where we meet that intercept. I'll have a look at the time in years here. So we've got a scale here from 20 to 30, this is the range, and it comes out this point here. So it's 20 to 30, each of the boxes must be 2. So that's going to be 1, 2, 3, 4. 4 times 2 is 8, 28. Is there 28 years here between them where we go from 30 to 40 to 50? There's your 20 years. And then 1, 2, 3, and then 4 there. That's 28 years as well. So the system, until 75% of all the original have decayed. So at this point here from 6, we're going to have 100% of our original. Right, then it goes down to 3 micrograms. So that's going to be 50. And then 75 decayed here at 1.5. So there are 2 half-lives. 2 times 28, because that is our half-life, is 56 years. The next question says, deuterium is radioactive. After 36 years, it's going to be key, only 10 grams remains until, from an original sample of 80, calculate the half-life. So for this one here, if we start off with 80, after 1 half-life we're going to have 40. After 2 half-lives we're going to have 20 grams. And after 3 half-lives we've got 10 grams. So 3 half-lives equal 10 grams. So if we've got 36 years and 3 half-lives, we want to work out how many years for each half-life is 36 divided by 3, 12 years. So we've got a sample here for 114 days. After this time it had a mass of 1.45 times 10 to the negative 4. And we know the half-life is 138 days. So, first step here, you want to work out from 414 divided by 318. So how many half-lives basically have we fitted in those 414 days, which will be 3 half-lives. And then after this time, at the end, it had a mass of 0.45 times 10 to the negative 4. So 1.45 times 10 to the negative 4. Now that's standard form. If if we write this out, we should have a number 1, 4, 5. It starts there. 1, 2, 3, 4. Yep, we jump forward. 1, 2, 3, 4. So 0.000145 grams. Now, that's at the end of it. Now, we know that there have been 3 half-lives. So, to calculate this one, 0.000145, and then we times it by 2, then times it by 2, and then times it by 2 again, because there have been 3 half-lives. Which will give us an answer of 0.00116 grams. Just here we have half-life graph, and it says how it changes with time. Draw on the graph to show how it can be used to find the half-life of uranium. So we have 1,000 for our count rate. Half of 1,000 is 500. Draw a line at 500. And then the point where it meets the gradient, that's where we go down. Ideally, as follows. And then half of 500 is 250. So again, we can draw a line to our gradient here, and then draw a vertical line on it as well. So you'll see we've got 2 half-lives ending up at 9,000. That one there is in between, so it must be 4,500. Which means how old is the Earth? 4,500 million years old. Next up, so the graph shows how the count rate from a sample of gold 198 changes with time. How would we calculate the half-life from this graph? So again, half of 600 is going to be 300. So we draw a line at 300 to our gradient, our graph. And then we mark the point where it goes down. Half of 300 is 150. So we draw a line at 150, and then the point where it goes down. And then we measure, after this, we measure the intervals between them. So it's important that we get the scale right. So this one here, we've got the time in days, we've got 2, and we've got 3 days here. Each of those little boxes there, there's 10 of them in between there, so they must be 0.1. So the time in days must be 2.7 because there are 3 boxes left. And then there's 4 here and 3 there. So again, that's 2.7. So the half-life is 2.7 days. I hope that helps you answering and mastering half-life questions.